Okay, let's do another balancing chemical equation example. One more. We're going to have iron solid plus hydrochloric acid is going to go to iron 3 chloride plus H2 gas. Okay? And now our job is to balance this chemical equation. Again, we're going to balance free elements last, okay? Let's count up to what we have here. We have one Fe, one H, and one chlorine. What do we have on this side? One Fe, we have two H's, and we have three chlorines. Okay, now this one's actually relatively straightforward. Both Fe and H are free. So we're going to balance the number of chlorines first. How are you going to do that? We need two more chlorines, right? So you're going to add two HCl molecules, right? Because you're only coming to HCl. So there's one here, so we're going to add two more, and we're going to end up with 3 HCl. I'll rewrite it. Although you wouldn't necessarily need to do that. Count up again. One Fe, 3 hydrogens, 3 chlorines, one Fe, 2 hydrogens, and 3 chlorines. So what do we need now? We just need one more hydrogen, right? We need one more hydrogen. They come in pairs of 2 though, right? So if I have 1 divided by 2, that means I need 0.5 more hydrogen. So I'm going to have 0.5 onto here. So I'll have 1.5 is what I'll have. Okay, let me rewrite it. Again, you can go below. Just let me rewrite it to make sure we're clear. Plus, like I said, we need one more hydrogen, right? They come in multiples of 2. So I went 1 more divided by 2 is 0.5. So we have 0.5 onto the stoichiometric coefficient, and I have 1.5 hydrogens, right? That'd be 3 hydrogens. But again, you're out there yelling, you can't have a decimal point of stoichiometric coefficient. You're correct. So what are we going to do? We're going to multiply through by 2 to get rid of the decimal. And so we end up with 2 Fe plus 6 HCl aqueous goes to 2 FeCl3 aqueous plus 3 H2 gas. Oops, forgot my subscript there. Don't forget your subscript. Otherwise you'll be wrong on a test. Let's quick count up. 2 Fe, 2 Fe, 6 hydrogens, 3 times 2, 6 hydrogens, 6 chlorines, 2 times 3, 6 chlorines, you're good to go. Okay? Hopefully that makes sense. Now, we're going to go on to precipitation reactions, aqueous reactions, all right? That's what we're going to talk about next. So, first let's take a look at aqueous solutions and solubility. Right? An aqueous solution is a homogeneous mixture. Involving water. Example, NaCl in water. Okay, you're going to make some noodles. Some people put salt in the water. As long as you don't put too much salt in, you're gonna end up with a homogeneous mixture. The salt will dissolve in the water and you won't be able to tell that it's there unless you taste the water, right? That'd be an example. In this particular case, we're looking at an ionic compound, okay? Now, many ionic compounds, most in fact, most ionic compounds are soluble in water. Oh, that's terrible. Okay, most ionic compounds are soluble in water. And wow, gotta be careful with my writing here. Sorry about that. Good grief. Soluble in water, okay, meaning they'll dissolve. Insoluble means it will not dissolve, okay? Insoluble means it will not dissolve. Also, in water, ionic components will usually dissociate, come apart. So actually, if I actually put NaCl in water, what actually happens is you get the ions come apart, and you get sodium plus and chlorine minus, okay? Is actually what happens if the ionic compound dissolves in water. It disassociates, it comes apart, all right? Now, not all ionic compounds dissociate in water. Some of them will be insoluble, like I said, meaning they will not dissolve in water. Now, to determine whether or not an ionic compound is soluble or insoluble in water, you will use this chart, and I'll send it to you. I'll send it to you in a PowerPoint, along with the homework. But I'm going to write it up here on the board so that you'll have it. We'll go through it real quick. Now, when you're checking to see if an ionic compound is soluble, you're going to look at the anion, the negative part, and then you will compare it to the chart. Then you will look at the cation part to check exceptions. And I'll just hold on, because we're going to go over what that means. So first we're going to have soluble ionic compounds. Okay. We're going to have our compound is going to contain, so soluble, right? And then I'm going to write the anion here, okay? We're going to have nitrate. We're going to have acetate. Ooh. Chlorine, bromine, and iodine all follow the same rule. And then we're going to have sulfate, okay? So those are the anions. Now these will normally be soluble. They're in the soluble table. They're normally soluble, right? But there are exceptions. I'm going to put the exceptions over here. For NO3, nitrate, there are none. So any compound that has nitrate is soluble. Acetate, there are none. Any compound that has acetate is soluble. Whatever it is, it's soluble. Now, for the halogens, chlorine, bromine, and iodine, exceptions, compounds that contain silver plus, mercury 2 plus, and lead 2 plus are insoluble. Okay, exceptions. So, if I have sodium chloride, right? You look at the anion first. Again, right? The anion's here, it's in a soluble table. Check the exceptions. Sodium does not appear as an exception. So sodium chloride is soluble. If instead I have silver chloride, okay, again, look at the anion first, chlorine, soluble compound, okay? Check exceptions. Well, silver shows up as an exception. So silver chloride is not soluble, it'd be insoluble, right? You put it'd be insoluble, right? What are the exceptions for the sulfate? We're gonna have strontium 2+, barium 2+, the mercury, and the lead. Okay? Let me write down the other table, the insoluble one, and then we'll go through some more examples. So this is one table. Again, I'll email these to you in a PowerPoint, but let me write out the next one and then we'll go over some more examples. This table is insoluble. Ionic compounds. And we're going to have compounds containing here I'm going to write down, we're going to have the sulfide, have our carbonate. Oh man, I cannot read this hardly. I think that's PO4, 3 minus, and then hydroxide minus. And then we're going to put the exceptions over here. And a lot of these are the same. We're going to have exceptions, NH4 plus the alkali metals. That's column 1, right, in the periodic table. And we're going to have cations, it's calcium, strontium, and barium. Those are the exceptions. Again, we'll go through some examples. Let me write this all out. The alkaline metals. This one's the same. And then for this one down here, we're going to have, again, same thing, NH4 plus, alkali metals, and we're going to have, again, calcium 2 plus, strontium 2 plus, and barium 2 plus. Okay, let's quickly look at an example, right? So if I have, I don't know, let's make it an example. Let's go check some examples. Let me just make a couple up. Alright, so let's look at these examples real quick. So here I have iron sulfide, right? So if you want to know if it's soluble or insoluble, again, look at your table, look at the anion. Well, it's right here, right? This is normally insoluble, right? Check the exceptions. Is the cation any of those exceptions? No, iron is not any of those exceptions. So this would precipitate, okay? It would be a solid. You put a solid there, S for solid. Write down insoluble or whatever. But it's a solid. It does not dissolve in water. Now what about sodium sulfide? Again, look at the anion, right? Normally insoluble. Check the exceptions. Well, sodium is an alkali metal, right? Group 1A, group column 1. So it is soluble. This would be aqueous. It's going to dissolve in water. What about chromium carbonate? Again, check the anion, carbonate's right there, right? Insoluble. Check the exceptions. Well, chromium's not any of those. Chromium's not an alkali metal, right? So this would be insoluble, it would be a solid. What about sodium hydroxide? Again, check the anion on the table, hydroxide, check the exceptions, NH4 plus alkali metals. Again, sodium is an alkali metal, so this would dissolve, it's soluble, so it would be aqueous. Don't confuse this S with soluble. The S here means solid, means it won't dissolve, okay? It's not soluble, it means solid. This is soluble, aqueous, means that it dissolved. What about barium hydroxide? Again, look here, hydroxide, right? Check the exceptions. NH4, alkali metal, calcium, strontium, barium. Again, it fits the exception. So this would be aqueous. Okay? Now again, I'll send you both of these tables. Let's look at a couple more examples. Using both tables. Right, using the tables that you have, printed them off, determine whether or not the following ionic compounds are soluble or insoluble. I'll just make some up, okay? So let me see here. All right, quick stop the video, quick to go through those problems using your tables. All right, now I know you stopped the video and you did those problems, let's go through them. So again, you look at the anion.